I'm Iain. Welcome back to the Northland Workshop. Today we're going to take this Craigslist find DeWalt 1030 round arm radial arm saw and turn it into the fine wood cutting machine you see here today. Now if you think you've just seen a video just like this from me, well, you kind of have. After I published the original video showing how to set this thing up, I talked to some of the nice people over at the DeWalt Radial Arm Saw group on the Delphi forums, and they were kind enough to give me some suggestions on how I could tune this thing up quicker than how I showed in the original video, and I would get a better end product, and also showed me that there was an issue with the arm clamp setup that I was unaware of. So because of that, and I want this video to be a guide on how to set up the radial arm saw in the best way possible, I went ahead and took down that video, re-edited it with the new suggestions, so that way this video will now have the best way to set up this radial arm saw and correct some of the little issues with it. So I just want to say thank you to the fine people of the DeWalt Radial Arm Saw forum. I'm going to leave a link to the forum in the description below, because if you are interested at all in radial arm saws, I highly suggest you go there. There's tons of information on these things. Even if you don't have a DeWalt radial arm saw, there are still tons of very nice people over there that are willing to help you set up your radial arm saw and answer any questions you might have. So without further ado, let's start setting up this radial arm saw the best way I know how. Very first thing I want to do is make sure this column is working the way it should. If I put my finger right on the intersection of the column and the column base, and I grab the end of the arm and I try twisting it side to side like I'm trying to miter, I shouldn't feel any movement between the column and the base, and I don't. The whole thing rocks a little bit because I've got it on a mobile base, but the column to column base is not moving. Now I want to grab the end of the arm and lift up and down on it, and I shouldn't feel any rocking that way, and I don't. That tells me that this column base is probably tight enough to this column. It might be too tight. The easiest way to tell if it's too tight is simply to try and raise it up and down. I can raise it up and down and turn it with one hand, which tells me it's not too tight. If on your saw you can't raise the column up or down without putting both hands on the crank, it's probably not too tight. Before you go messing with this bolt and the other bolt that's on the back side to adjust the clamping force on this, I highly suggest you crank the column all the way up, spray it with WD-40, and crank it down. Then crank it back up, and you're going to see lots of junk coming out of this base attached to the WD-40. Take a rag, wipe it all off, and crank it back down again. Crank it back up, wipe it off, another spray of WD-40. Do that several times, each time cleaning off all the junk that it pulls back up, and what you're going to find is going to work perfectly afterwards. The final time you do it, crank it all the way up, wipe every speck of WD-40 you can find off the column, and crank it back down, and it's good to go. You don't want to just douse the thing in WD-40 and leave it there, because WD-40 leaves an oily residue that will attract sawdust, and if you get sawdust packed in there, you're going to be right back to the arm sticking again. So 9 times out of 10, if you're having trouble adjusting this, it's not that the thing's too tight, it's that the thing needs cleaning. I've taken the end cap off the arm, and I've very carefully slid the entire carriage assembly out and set it on the table. You want to be careful when you take the carriage out because it's heavier than it looks and you don't want to drop it. The reason I did this is we need to fix the bearings on the carriage, and we also need to clean the ways. Now this is one way, this is the other way. They're the half-round grooves cut in the arm that the 4 bearings on the top of the carriage ride in. And under normal operation, these things get packed with sawdust and grime, and as the saw slides back and forth, those bearings just continuously pack stuff into these grooves until it can't move correctly, or it just doesn't move at all. So we need to clean these things out. Now you want to be careful with these ways that you don't slide your finger along them, because they could have sharp edges on the top or the bottom, and you don't want to cut yourself. The best way to clean these ways that I've found is to just take a rag with mineral spirits and just keep cleaning in them. If you have to use a wire brush, if it's that bad, use a brass wire brush or a nylon bristle brush. You don't want to use a steel wire brush because you don't want to scratch or damage these ways. These are precision machined parts that once they're damaged, they're damaged. What I'm going to do is just continue to clean these ways, switching spots on the rag until eventually they come up clean. It may take a little while, but you want to make sure every little bit of grime is removed from this thing. Otherwise, all the adjustments we do in the future are for nothing. With the ways sufficiently cleaned, I want to take a clean part of the rag and spray some WD-40 on it. Now I want to take the WD-40 on the rag and just wipe it on the ways. This is just to give the cast iron a little bit of rust prevention. We're not trying to lubricate the ways. They don't need any lubrication. I just don't want them to rust, because rust will impact the accuracy of this thing. Now I can turn my attention to the carriage, and as you can see, there's caked on dust up at the top and all around the motor. It might be tempting to take some compressed air and try and blow this all out, but you really don't want to use high pressure air on this thing, because you could actually force the dust farther into the motor or the bearings, and that'll just make matters worse. What I like to use is one of these little workshop blowers that's really just a mini leaf blower. It moves a lot of air, but it's not at high pressure, so the chances of it forcing the dust past seals and bearings is rather small. But the best thing I've found to clean off this dust is to simply take an old paintbrush, preferably one of these cheap ones with the really stiff bristles, and just keep brushing. Again, this is just years of dust on here. It'll come off fairly easily. This is the detent pin that either sets the motor in ripping mode or crosscut mode. What I want to do now that I've got it all cleaned off is to give it just a little spray of WD-40 and work it up and down several times, spin it a little bit, make sure it's good and freed up. And once I'm happy with how it works, I'm going to come back and take the rag, lift up on it, and try and wipe as much of that grime that it's just broken free off that control rod. I'll set it down, lift it up again, wipe it again. The whole idea is I'm trying to clean off as much of the junk that it's going to pull out there as possible. At the same time, I'm also trying to clean off as much of the WD-40 as I can, because I don't want to leave lots and lots of oily residue on here, because that's going to collect dust and I'm going to be right back here cleaning it again. Remember, it's not so much that we're lubricating this thing as we're trying to clean this thing. Now in terms of lubrication, there is something that we need to deal with, and that is these bearings up at the top. This one is very, very crusty, and the rest of them aren't far behind. This one, however, is okay, because I've already given this one the treatment. I've cleaned off the top of these bearings as much as I can, and now I need to try and get the crusty grease inside these bearings to be less crusty. And the easiest thing I've found, and I did this about 10 years ago for the Rockwell bandsaw, and it's been fine ever since, is to spray the bearings with WD-40 and then spin them to get the WD-40 down inside the bearings. The idea behind this is that the solvents in the WD-40 will hopefully try to loosen up some of that old caked on grease and get it just a little bit more like normal grease. And then I can go ahead and wipe off the excess. And I'll just sit here and spin the bearings for a little while, and I will do that same thing to all the bearings. Now I want to put a drop of 3-in-1 oil on each bearing just to help it stay lubricated for a while, because the 3-in-1 oil will stick around long after the WD-40 is gone. Now that they're all running like they're supposed to, I can go ahead and take some mineral spirits on the rag and clean up the outside of the bearings, because I want to make sure there's no gunk on the outside and that this thing hasn't worn any flat spots on the outside, because that's going to affect the next step when we set the tension on these bearings. This is the handle for the yoke assembly. This is the top of the carriage, as it would be facing me standing in front of the saw. On the right hand bearing on the front, you'll notice there's a hole right in there, and that has an Allen head set screw in it. What I want to do while I have this thing out is loosen that set screw up about one whole turn, maybe a little more. I want to do the same thing to the bearing directly behind it. The bearings on this side, the blade side of the carriage assembly, don't have any set screws. They're not on cams. Now I can go ahead and put the carriage back in the arm. I want to make sure the carriage clamp goes in. And I want to be very careful of these rip scales. I don't want to damage them. We'll set those later, but for now, don't want to damage them. And this thing moves nice and freely, back and forth. Look at that thing go. Okay, believe it or not, it's not supposed to move that freely, because I can actually rack this thing up and down in the upper arm, and that's no good, because if it chatters up and down as we cut, it could climb at me. The other thing is I'm going to lose some accuracy because it's able to scoot all around in here. So we need to adjust these bearings to give us a tighter fit in this arm. But it is nice that I can slide it back and forth and not feel any kind of irregularity in the sliding. So that's a good sign. It's time to check the preload on the bearings. And what I'm going to do is I'm actually going to put my thumb on this bearing right here and push on it as hard as I can and push the carriage in towards the column. Now I'm able to stop that bearing from turning as I push it in using my thumb. That means I don't have enough preload. I should not be able to stop this bearing while I'm pushing this carriage. I want to make sure that when I do this test, I'm always pushing away from my finger, because otherwise I might pinch it in between the roller and the way, and that would kind of hurt. Since I know that the preload is too low on this side, I'm going to go ahead and tighten it. To adjust the preload on the bearings, I need a 9/16 wrench to loosen up the nut down below the bearing, and I'll use a 5/8 wrench to actually turn the post that is off center, so as I turn it, the bearing will either get closer or farther away from the way in the arm. And as you can see right now, not enough preload. I can stop it with my finger. I'll turn it a little bit, try it again. And it was much better, but I could still stop it briefly. So I will turn it just a little bit more and try that. That's perfect. So what I want to do now is, while holding the post in its position, tighten up the nut underneath, and then tighten up the set screw. I find it a royal pain to try and adjust the bearing pretension on the back bearings the same way, because it's very hard to get the wrench up in there. So what I like to do is to actually take the carriage out and spin it around and put it back in. Now I can repeat that same process that I did on the front set of bearings with these bearings, and it's much easier to get to. The first step in making a new table for this radial arm saw is to cut the piece of plywood. Unfortunately, I can't cut the plywood with this radial arm saw because it's disassembled right now, which is why it's always good to have a backup radial arm saw with which to cut parts for the second radial arm saw. Every radial arm saw I've ever encountered comes with 2 or more of these little movable portions of the table. And what they do is give you more flexibility in where you place the fence. The fence gets clamped between these and the main part of the table, and you're free to move it around for different size rip cuts and different operations, like using a molding head cutter and turning it into a shaper, which is what the big notch is for. I got lucky in that I got these original boards with it, so it's going to be very easy to replicate these things because I know the dimensions they're supposed to be. If your saw didn't come with the original table, or it came with part of the table but it's missing these, if you find the manual for your saw, most manuals will tell you what the dimensions for these tables are, and of course you can always make them to your specifications for what you're going to use the saw for. This Rockwell, for instance, originally had 3 different boards to it, and during one of my projects I needed to place the fence in between one of them, and it was easy enough to rip that in half, and now I have 4 boards for it. So the nice thing about this, it's very flexible. If you can't find the original ones, feel free to make it up as you go along. However, I've got the original ones, and I think for this purpose they're going to work just fine. The easiest way to replicate one of these boards is to actually place it in between the fence and the saw blade on my radial arm saw. That way I know when I rip the piece of plywood, it's going to be the exact same dimension. And I want to adjust it so it just barely rubs on that blade. And I can go ahead and lock the carriage in that position. I should remind everybody that when ripping on a radial arm saw, you need to feed the wood opposing the rotation of the blade. The blade is turning back this way, so I need to push the wood in this direction. If I don't, it could grab the wood and launch it, at my new radial arm saw, and that would be detrimental to it and my nerves. So I just want to be careful of that. I'm using a drill bit that just barely fits through the hole in the old table, and I'm spinning it while tapping it with a hammer in order to mark the center location of that hole. I'm going to do the same thing to all the holes, take this table off, and then start drilling the counter bores with a Forstner bit. I'm using a 7/8 Forstner bit to counterbore for the screw heads because I need to make sure they're down below where the saw blade's going to cut in this thing. And I'm using the 7/8 size bit so that way I've got a little bit of wiggle room to adjust this thing to make sure all the holes line up with the support brackets. With the old top clamp back into place over the counterbores, I can now use it as a guide to drill the actual screw holes. On this particular saw, 6 of the screws that hold the top to the rails are also the supports for the rails in the front. As you can see, I can push it up and down quite a bit. They have jam nuts that have to go between the rail and the base of the saw, and I need to remember to put those on now before I screw these in any farther. Otherwise, I'm going to have to back them all the way back out in order to get the jam nuts in. Now I don't want to tighten anything down just yet. I've set the saw to its 90-degree detent for the arm, and I've spun it to the in-rip position. I've also installed this old saw blade, and I've lowered it down so that way I have as much of the blade contacting the back edge of this table as possible. What I want to do is try and get this table to be parallel to that saw blade. The closer I can get it to parallel, the easier it's going to be to square up this arm afterwards. I still might have to fine-tune it a little bit, but it'll be pretty close right from the get-go as long as I keep that gap parallel. I'm ready to level the table, and the first thing I need to do is start by cranking up the height adjustment. Now what I want to do is loosen up the arm clamp and also swivel the motor so the arbor is pointing straight up and down. Just like that. Because now what I'm going to do is move this around and get the height of everything to be the same. Everything droops, even this cast iron arm, and the frame flexes a little bit. So what I need to do is get it so that this table is bent parallel to however this arm droops as it moves around. And that's what those nuts on the really long screws are for. When I first start leveling this saw, I have to choose a spot to be the reference spot, that everything else is going to be brought up to that level. In this case, I decided to try right in the middle with this adjusting screw right here. So I set the jack nut on it, So that way there's about 1/2 inch between the metal support underneath and the metal base. I went ahead and I tightened the nut on the very bottom of it, locking it all together. So now this point is fixed, and I'm going to make everything else be in the same plane as that. You could take a dial indicator and attach it to the motor and use it to level everything. This is a woodworking machine, not a Bridgeport mill. You don't have to go out and buy a dial indicator to zero in your radial arm saw. If you have a dial indicator, it's perfectly fine to use it, but it's not a requirement. What I'm going to do is use a business card and the scrap that I cut out of the notch for the arbor. And what I want to do is take the arbor on the motor and placing the business card on the scrap piece of wood, I'm going to lower it down until it just barely rubs. Just like that. So there's friction, but I can move the business card. Now what I can do is move it as far over as I can on top of this other metal support, and I will check to see how it is. And that is way too loose. So that metal support has to come up. So what I'll do, using a 1/2 inch wrench, is start adjusting this side up until I get the same amount of friction between the business card and the end of the saw arbor. And right there, I have the same friction. So that one's okay. Now I can go ahead and move the arbor over here and check to see how it is. And that needs to go up quite a bit. So I'll repeat that process, moving this thing all over the table and adjusting as I go until I get it so it has the same friction between the business card and the scrap piece of wood all over the place. And it might take a few adjustments to get everything in the proper plane, because as I adjust one side up, the other side might start adjusting down. So take your time and don't be afraid to go back to the ones you've already adjusted and tweak them some more to get everything to work the way it should. The more accurate you are in this step, the better it's going to be in the long run for the saw. I've reinstalled the blade, and I want to see if the blade is square to the new table. And so it's got the 90-degree detent engaged, so this is where the motor thinks it's square. Let's see. Now that is absolutely perfect. There's no way I could get it any better than that if I tried. But let's go through the motions of squaring it in case your saw doesn't land on square. What we want to do is unclamp that, and there's 2 screws on here. And we're going to remove the AMF badge. Now, depending on your brand of saw, it might be slightly different, but the controls for adjusting the 90-degree detent are going to be in this hub somewhere. On this one, there are 3 Allen head screws. You want to loosen up the 2 outer ones with the detent pin still engaged in the 90-degree hole, and you can tip it up or down and then tighten those back up to lock it in place once the blade is straight up and down. In this case, it's already set to 90, so I don't have to mess with these, but if it didn't end up that way, I would have to adjust those 2. At this point, I can go ahead and put the AMF badge back on, and I can adjust the little pointer to read 0 degrees, because that's what this is at right now. So this little pointer just gets set to read 0. That way, as I adjust this to different angles, I'll be able to read out what the angles are. Now that I know the saw is 90 degrees to the table in this orientation, I need to make sure it's 90 degrees this way. So that way I'm not cutting a miter when I want to cross cut something. And what I'm going to do is take this framing square that I know is square and hold it up against the back edge of the table, because that's what the fence is going to clamp up against. So if this isn't square to the back of the table, it's never going to be square to the fence. I want to butt it right up against one tooth of the saw and pull it out, and it's got a tiny bit of space. If I push it back, it's now dragging on the square, which means this whole thing angles back this way ever so slightly. To fix that, what I need to do is unclamp the arm and pick up on the 90-degree detent and swing this arm just a little bit this way. Now what I'll do is recheck with the square and make sure that tooth just barely grazes along that square the entire travel. Now that it follows the square through the entire travel, I've gone ahead and clamped the arm in place. Now we need to adjust this detent so that way it returns it to this 90-degree spot every time. To do that, I'm going to loosen up these two set screws right here and adjust the big threaded pivot back and forth until this falls down into that detent. I've pulled it away from the wall so I can work on it, and I'm looking straight down on it, and I can see the wedge part of this little cam is too far to the back. So what I need to do is turn this thing out about a quarter turn, and I will turn this one in about a quarter turn. And it's moved it forward a little bit. I need to do it just a little bit more. I want to gradually adjust them until this wedge centers itself right in that space. And that looks pretty good. So what I need to do, just snug these two things up because I don't want any play side to side in this little lever. It should be a snug fit, and it is. And looking at it, it looks as if it is centered. So I've just snugged those up. Now what I want to do is test this setup to see will it bring it back to 90. So first thing I want to do is unclamp the arm, pick up on this, swing it away from 90, bring it back, and bring this down into its spot. And now I can go ahead and clamp the arm. And I'll test it with the square to see if it's actually square. If it is, I don't have to mess with this anymore. It's all set. If it's not square, I will repeat that process, fine-tuning this until it locks it in square every time. With the miter detent all set, I want to turn my attention to the arm clamp. And as you notice, this arm clamp locks in the down position. That's not how this is supposed to work. It's actually supposed to lock in about the 10 o'clock position and then unlock in the 2 o'clock position. That's why it has this big roll pin. So we need to adjust this so that way it gets tight right about here. The way we adjust where this thing clamps is through this nut right here. You'll notice there's a cotter pin behind here. That keeps this nut from rotating under normal use. We need to get that cotter pin out of there so we can turn this with a wrench. To do that, I'm just taking a nail set and putting it right on the end of the cotter pin and just tapping it out. Now I can go ahead and hold the clamp handle right where I want it to clamp down on the arm, and I can adjust the nut so that way it gets tight right about there at the 10 o'clock position. Now that it does, I can go ahead and reinstall the cotter pin. And to do that, I just tap it down. Just like that. So that sets it so it locks right about here. Now the issue is that I want to adjust this roll pin so that way it doesn't get any farther that way than about the 2 o'clock position. So to do that, I'm just going to tap this roll pin out a little bit. There. So now when I loosen it up, that roll pin stops it from opening any more than right there. So that should be perfect. The final two adjustments we need to make to this saw involve what's called the heel of the blade. And what that is how parallel the blade is to the cut being made. So in this case, I've got it in the cross-cut mode. I want that blade to be perfectly parallel with the line it's cutting. So that way it doesn't burn the wood or try and climb up the side or do anything nasty like that. It's very important that it truly does track parallel to the line being cut. Now if I exaggerate this for clarity, if I tip it like this, it's still moving in a straight line, but the blade's at an angle. So that would be heeled that way. Same with if I was to move it this way and it tries to go through the wood sideways, I'm still making a straight cut. It's just the angle of the blade is moving in a way that's not parallel to the cut line. So it's not trying to make a miter, it's just not going through the wood parallel. That's what we're trying to correct for. Now, the same thing happens if I tip this motor horizontal. If that blade is tipped this way or this way when it's horizontal, that's a problem as well. So those are the two things we need to do. We need to make sure it's not tipped this way or this way, and it's not tipped this way or this way. This is the vertical heel, this way is the horizontal heel. I'm taking this back cover off so that way you can get an idea of what's going on. You don't actually have to remove that cover in order to make the heel adjustments. This is just to give people an idea of what's going on in here. This is the back of the motor yoke. Directly opposite this is where the handle is, and the bevel control clamp is directly in line with this on the other side of the motor. This is the 3 set screws that adjust the heel of the blade. You've got the one on the bottom that adjusts the horizontal heel. You've got the 2 up top, they adjust the vertical heel because they can move that rear pivot point side to side and therefore move the blade side to side. What we want to do is adjust the horizontal heel first, because adjusting the horizontal heel requires moving these 2 set screws, which is going to throw off the vertical heel. No matter how careful we try to move these screws, we're never going to get them back in the same spot, and when we're talking about thousandths of an inch out of whack having a significant effect on the quality of the cut, we want to get it right. So, one thing you want to be careful of, they have lock nuts on these set screws so that way they don't back out under use. You want to be careful of these set screws. They are very brittle, and I've heard horror stories of people snapping them off, and then you're in a world of hurt trying to drill out a set screw. You don't want to do that. So be very careful with these things. If they're not turning, try and figure out why. Don't just brute force it, because it probably will shear it right off. When we do the horizontal adjustment, and again we want to do that first because that's going to affect our vertical adjustment, if this bottom set screw needs to go up, so the back of the motor needs to go up a little bit, what we need to do is back off these two set screws to give it a little bit of space to then pick the pivot point up. If we need to lower it down, we drop it down with the set screw, and then we're going to have to advance these two a little bit to take up the slack. So just remember, no matter which way you go, you always want to loosen the opposite thing first. So if it needs to go up and I need to turn this in, I need to loosen these two first. Same with the vertical adjustment. The vertical adjustment, you can ignore that bottom set screw and just do the two top ones. But again, if I need to move this pivot point that way to correct the heel, I need to back this one out first and then turn this one in. Otherwise it'll bind up and the set screw will probably just snap right off. First thing I need to do is to see if the blade tips this way or this way in the cut when it's horizontal like this. This is important if we're going to use it as a shaper with a molding head cutter, or we raise panels or cut grooves with the saw blade in this orientation, because if it's not perfectly straight, it could get burning in the cut, or we could get kicked back, and nobody wants that. So what I've done is I clamped the triangular piece in the slot for the fence facing up. I've marked the tooth of choice. It just barely rubs on the tip of this piece of plywood. And what I can do is pull this whole thing forward, back it up with that tooth still in line, and it just barely rubs like it did in the other plane. So I know one end isn't higher than the other. If it was, I could use that bottom set screw that I talked about earlier to drop it down that way, or pick the back end up depending on which way it needed to go. So that thing is fine. The final test we need to do is to check the heel of the blade in this direction. To do that, I've got this wedge-shaped piece of plywood in place of the fence. And what I've done is I found one tooth that it rubs up against, and I've marked it with the Sharpie so that way I remember that it's that tooth. And I got it so it just barely touches. Now if I push the blade back and I bring it around for that same tooth to come in contact with it, I see that it does just barely hit, just like on the other side. So that's good. That tells me it's not tipped this way and it's not tipped that way, because if it was tipped this way, it wouldn't be hitting right now. And if it was tipped this way, it would be seriously digging in right now, not just grazing the surface like it is. I've got the blade up so it's not contacting the table, and I'm going to hang on to the handle and turn it on. Then I'm going to slowly lower it down so it just cuts into the table, and we can push it back through the fence, making the first 90-degree cut.